video we're going to look at solving simultaneous equations. Here we have a simultaneous equation. The first thing we look for is the coefficients of the letters, and we're looking for coefficients which have the same value in terms of the number that's there. So here we have a 7 and a 7, they are the same, and here we have a 5 and a 2, they're different. Now as long as one of them's the same, you can continue with the question quite easily. So these 7s here are the same, so that's good. Once you've decided which letter has the same coefficient, then you decide whether you're going to add or subtract these equations. So here we have a 7 and a 7, and they're both positive, they're both plus 7 and plus 7. And if they're both positive or both negative, then they have the same sign. And if they have the same sign here, then we subtract the equations. So I'm going to write a subtract here, and I'm going to subtract the equations. So I do 7x, subtract 7x, well that gives me nothing. And then 5y, subtract 2y, well that gives me 3y. And then 19, subtract 16, and that gives me 3. And if 3y equals 3, I can solve that very easily because I do 3 divided by 3, which gives me 1. So I've got y equals 1, which is half of the solution to this simultaneous equation. What I then do is draw a line to separate my working out, and I pick one of these equations to work with again. Now it won't make a difference which one you pick, but I would advise picking the one that you think is going to be the easiest to work with. For example, try to avoid negatives. So I'm going to pick the first one in this case, and I'm going to write this first equation out again, only rather than writing y here, I'm going to write 1, because I know that y equals 1. So I've got 7x plus 5y, but I know that y is 1, so it's 5 lots of 1, and this equals 19. Now this is a normal linear equation which I can solve quite easily. So we have 7x plus 5 1s. Well, 5 1s, that's just 5, equals 19. And the first thing you would do in this is subtract 5 from both sides. So if I subtract 5 from the left hand side, it's gone. If I subtract 5 from the right hand side, I get 19 subtract 5. And 19 subtract 5 is 14. And then I'm left with another easy equation, 14 divided by 7, well that's just 2. So the solution to this simultaneous equation here is y equals 1 and x equals 2. Let's have a look at a different example then. Now in this case, again, I look for the coefficients being the same, so I have an 8x here and a 6x here. Well, they're different numbers, but fortunately I have a 6y here and a 6y here, they're the same number. So I can work with these y's. Now again, I look at the signs. In front of this one here I have a positive 6x, and this one here I have a positive 6x. Oops, let me get rid of that. And if the signs are the same, then you can subtract the equations. So 8x subtract 6x, that's 2x. And 6y subtract 6y, well that's nothing. And 52 subtract 42, that's 10. So if 2x equals 10, then x must equal 10 divided by 2, which is 5. So we've got half of the solution here. So we separate our working out, and we pick an equation again. I'll pick the second equation this time, and so I'll write it out again, but rather than writing this x here, I'm going to write 5, because I know that x equals 5. So I've got 6 lots of 5, because that's x, plus 6y equals 42. And then I solve as I did before, so 6 lots of 5, well that's 30, plus 6y equals 42. And then I subtract 30 from both sides, so this one will go, and I need to subtract 30 from this side as well. So 6y equals 42, subtract 30, in which case 6y equals 42 subtract 30, well that's just 12, in which case y equals 12 divided by 6, which is 2. So the solution to this simultaneous equation is x equals 5, y equals 2. Right, a third example then. Now in this case, the x's, I've got 7 and 5, that's different, but the y's I have 3 and 3. So 3 and 3, that's okay, they're the same, I can deal with that. But note that this time, the signs for the 3 and 3 are different. We have a positive here, and we have a negative here. Now, if the signs are different, you're not going to subtract the equations, you're going to add the equations. This will allow one of the letters to be eliminated. So 7x plus 5x, that's 12x, and 3y plus negative 3y, well, that actually comes out as 0, because when you add a negative, it's the same as subtracting. So that disappears, and then 33 plus 3 gives you 36. And if 12x equals 36, 1x must be 36 divided by 12, which comes out as 3. So we've done half of the work, so we draw a line and separate our working again. And I'm going to pick the first equation this time because I'm not so happy with this negative here. It would work if you did the second one, but I'd advise staying away from it. So I'll write this one out again, 7, but I know what x is. X is 3, I've already worked that out. So I'll write a 3 in here, plus 3y equals 33. And then I go ahead and solve this. Well, 7 3s, that's 21, plus 3y equals 33. And then I'll subtract 21 from both sides. If I subtract it from this side, it cancels out. So I've got 3y. And if I subtract it from the other side, I write 33, subtract 21. And then 3y equals, well, 33 subtract 21, that's 12. In which case y must equal 12 divided by 3, which is 4. So the solution to this one is x equals 3, y equals 4. Okay, one final question then. So again, I begin by looking at the numbers. I've got 9 and 5 for the x's, that's no good, they're different. And I got 3 and 3 for y, that's good, they're the same, I can deal with that. So you draw yourselves a line, and then you make the decision whether to add or subtract. Now, this time, even though this is negative and negative, the signs are the same. And that's what's important, whether these signs here in front of the 3's, which are going to eliminate, are the same or different. If they're the same, then you subtract the equations. So 9x subtract 5x is 4x. And this is why you subtracted the equations, because a negative 3y subtract a negative 3y must be 0. Because when you subtract a negative, it's just like adding, in which case we've got negative 3y add 3y, which must be 0. And then similarly, 21 subtract a negative 3, well, if you subtract a negative, that's like adding, so it's actually 21 add 3, which is 24, in which case x must give you 6, because 24 divided by 4 is 6. So that's half of the solution. So again, we pick an equation. Now we can't avoid negatives really in the y sense, so I'm going to pick the first equation. I've got 9 lots of 6, because I know that x equals 6, because I've worked that out. Subtract 3y equals 21. And 9 sixes, well, that's 54. Subtract 3y equals 21. Now, this equation is a little bit more difficult to solve because of the negative 3y here. What I would suggest doing is actually making that a positive 3y by first of all adding 3y to both sides. So if I add 3y to this left hand side here, that 3y will cancel out. I'd be left with just 54. And if I add 3y to the other side, I get 21 plus 3y. And then what I would do is subtract 21 from this side so that I'm left with just the 3y. And if I do that, I need to subtract it from the left hand side too. So 54 subtract 21 equals 3y. And 54 subtract 21, well, that's 33 equals 3y. And at this point you might want to flip it round into a form so that the y is on the left, because you're more familiar with that. So 3y equals 33, in which case y must equal 33 divided by 3, which is 11. So the solution to this one is x equals 6, y equals 11. Okay, here are 4 questions for you to have a go at. If you press pause and have a go at these questions, and if you press play, then I'll take you through the answers to them. Okay, here are the answers then. So for the first question, we have a 3y and a 3y, and they're both positive, so I subtract them. And 5x take away 3x, well, that's 2x. And 3y take away 3y is nothing, and 23 take away 15 is 8. And if 2x is 8, x must be 8 divided by 2, which is 4. So I go on to the second part of the equation then, and I'm going to use the first equation. So 5 lots of x, which is now 4, which we found out, plus 3y equals 23. 5 fours, well, that's 20, plus 3y equals 23. And subtract 20 from both sides, so you subtract it here, and you subtract it here. and well, 23 take away 3 is 3, so 3y equals 3, in which case y must equal 1. Okay, for this next one, we've got 8x and 6x, and that they're not the same. We've got negative 4y and negative 4y. They are the same. Both signs are the same as well, in which case we'll subtract the equations. 8x take away 6x, 2x. Negative 4y take away negative 4y, well that's just like adding 4y, so it's 0. And 44 take away 34 is 10. And if 2x equals 10, then 1x must be 10 divided by 2, which is 5. Okay, the second part of the solution, we've got 8x, and x happens to be 5 this time. Subtract 4y equals 44. 8 5s are 40. Subtract 4y equals 44. Now this is one where we have a negative 4y again, which is difficult to deal with. So I would suggest adding 4y to both sides. Add 4y to this side, and that one cancels out. So we need to add 4y to this side as well. And then we've got 40. I would now subtract 44 from both sides. So we have this. Now 40 take away 44 is negative 4 equals 4y. In which case 4y equals negative 4 if we just switch it around. And then y must equal negative 1. Because 4 divided by 4 is 1, but we've got a negative sign. Okay, let's look at the next question. We've got 7 and 7 the same, only this time they're different signs. We've got a positive and a negative, and if they're different signs, you add the equations. So we've got 11 plus 5, which is 16, so we have 16x, and these will cancel, and then 47 plus 1, which is 48. And if 16x equals 48, x is 48 divided by 16, which is 3. And then for the second part, we've got to get y, so we've got 11x, but we know that x is 3, plus 7y equals 47. And I chose the first equation that time because there was a negative here that I didn't fancy dealing with. So 11 3s are 33, plus 7y equals 47. Now subtract 33 from both sides, and we end up with 7y equals 47. Subtract 33. So 7y equals, well, 47 subtract 33, that's 14, in which case y must equal 14 divided by 7, which is 2. For the final question, we have the y is the same this time, so we're going to subtract the equations because they're both positive. Only this time I'm going to subtract this equation, the first one, from the second one. So it's a bit like working the other direction. The reason for this is if I do 3 take away 8, I will get a negative 5. Right, it would still work, but you'll also get a negative over here, and I much prefer dealing with positives. So 8x subtract 3x is 5x. 6x subtract 6x is, 6y subtract 6y is 0. And 46 subtract 36 is 10. So we end up with 5x equals 10, in which case x equals 2. And for the last part, we have, I'll use the first equation, 3 lots of 2 plus 6y equals 36, in which case 6 plus 6y equals 36. And I'm going to subtract 6 from both sides, so 6y equals 36, subtract 6, so 6y equals 30, in which case y must equal 30 divided by 6, which is 5. And that completes this video on simultaneous equations.